Welcome to today's lecture. The subject is chemistry. Today we'll be looking at acid-base theories. The topic again, acid-base theories. The first theory is Arrhenius theory. How does Arrhenius see acid and base? According to Arrhenius, an acid An acid is a substance that produces hydrogen ion when dissolved in water. So if HCl is dissolved in water, it will give H plus, Cl minus. If tetraoxosulfate 6 acid H2SO4 is dissolved in water, it will give you H plus and SO4 2 minus. If triazonitrate 5 is dissolved in water, it will give you H plus and NO3 minus. Since each of the acids can produce hydrogen ion when dissolved in water, since HCl, H2SO4, HNO3 can produce hydrogen ion, that is, hydrogen ion, H plus, when dissolved in water, then they are acids. A base is a substance that produces hydroxide ions, OH minus, when dissolved in water. NaOH giving you Na plus plus OH minus. KOH giving you K plus plus OH minus. CaOH2 giving you Ca2 plus 2OH minus. Since sodium hydroxide, potassium hydroxide, calcium hydroxide can all produce OH minus, that is hydroxide ion, when dissolved in water, then they are bases. One limitation to Arrhenius theory is that it is tied to the solvent water. It works only in aqueous solution. So Arrhenius theory becomes invalid in non-aqueous solution. That will take us to the second theory, Bronsted-Lowry theory. Let's look at the Bronsted-Lowry acid. An acid is a substance that can donate a proton, while a base is a substance that can accept a proton. Let's see an example. This is ethanoic acid. Undergoes dissociation in water to form ethanoate ion and hydrogen ion. So, because this is CH3COO minus, it has the ability to accept a proton. So it becomes the conjugate base. Why this becomes the conjugate acid? Because it has the ability to donate a proton. I want you to take note of this. Weak acids produce strong conjugate base, while strong acids produce weak, very weak conjugate base. Very weak conjugate base. So I want you to take note of that. So let's look at the next example. HCl plus H2O. This is Bronsted-Lowry acid, Bronsted-Lowry base. So if these two react, it's going to get ozonium ion and chloride ion. So the ozonium ion, because it has the ability to donate a proton, becomes a conjugate acid. The HCl has the ability, the Cl minus, the chloride ion, has the ability to accept a proton. It becomes a conjugate base. Cl minus is a very weak conjugate base. Why? Because it is coming from a strong acid. So then HCl and Cl minus chloride ions are acid-base conjugate pairs. Oxonium ion H3O plus and H2O are conjugate acid-base pairs. We take another example. This is trioxynitrate 5 acid, nitric acid, and water. Bronsted-Lowry acid, Bronsted-Lowry base. So when they react, you're going to get H3O plus, which is the conjugate acid. Why is it the conjugate acid? Because it has the ability to donate a proton. NO3 minus becomes a conjugate base. Why is it a conjugate base? Because it has the ability to accept a proton. Now, HNO3 and NO3 minus are acid-base conjugate pairs. And H3O plus and H2O are conjugate acid-base pairs. I want you to remember that an acid is a substance that can donate a proton. A base is a substance that can accept a proton. So you have to commit that to memory so that as you go along, you don't mix everything up. So what's the advantage of Bronsted-Lowry? It works in aqueous and non-aqueous solution. Let's see sodium hydroxide. If it dissolves in water, it's going to give you Na plus, OH minus. So the Na plus is a conjugate acid, while the OH minus is a conjugate base. Don't forget conjugate acid because it has the ability to donate a proton. Conjugate base because it has the ability to accept a proton. Strong bases produce weak conjugate acid. Strong bases produce weak conjugate acid. Very weak conjugate acid. They are too weak to perform the action of an acid. This will take us to Lewis theory, which is a third theory under acid-base theories. So according to Lewis, an acid is a substance that accepts an electron pair. A base is a substance that can donate an electron pair. So the word electron pair means a lone pair of electrons. That means the acid and the base here are seen as the reactants. So the base has the ability to donate a lone pair of electron. That lone pair of electron is what is called that's what is called the electron pair. That means a base is a substance that donates an electron pair. So the base donates the lone pair of electrons, and when this is done, a dative bond is formed. So Lewis theory actually leads to a coordinate product. Okay, so let's see examples. This is the Lewis acid, boron fluoride, Lewis base, ammonia. So ammonia here has the ability to donate a lone pair of electrons, while the boron fluoride, which is the acid, has the ability to accept a lone pair of electrons. And when that happens, you form a complex compound, ammonia, boron trifluoride complexes or complex. So this is a complex compound. And the bond here that is very visible here is a dative bond. So Lewis theory leads to a dative bond formation. Copper 2 ion and ammonia will give you also a dative bond. The product form is as a result of a dative bond. So the product form is tetraimine copper 2 ion complexes. With silver ion and ammonia, you have another complex, silver diamine complex or complexes. I'll see you in the next lecture.